Hey there, GISers. It's Angela. So, this is really like our first official, aside from our welcome week, it's really our first official lecture into learning about what GIS really is. So, GIS is what it stands for, is acronym for Geographic Information Systems. So, at its very core, GIS stands for the word geography. And I think it's for that fundamental reason that many of us come to GIS not knowing what it is. Because if we don't know truly what geography is, then we struggle with trying to figure out really what GIS is in the first place. So we come to this awareness and this understanding of what really geography is. And interestingly enough, many of us come to geography in different ways. So we've experienced geography in the fourth grade. We've experienced geography in high school, perhaps some in very positive and sometimes perhaps very interesting and uncomfortable ways where perhaps we were forced to memorize place locations, and that wasn't really a lot of fun. Maybe there were for a few of us that found that mildly amusing, but for most of us, especially as Americans, we don't really know what geography is. Now, maybe once you get into high school, you take AP human geography, in which you have to memorize a lot of terms as well. And in geography, there are many aspects. There are the human aspects, the physical aspects, and the technological. And the technological is where GIS comes in. GIS is learning how to map using a computer program. Now we have the ability to map online as well in an online forum and setting while using AGOL, which is ArcGIS Online. And we're going to be utilizing that in this course too. So, a brief overview of what is GIS, components of a GIS data, and how a GIS works. So, here we go. What is GIS, also known as Geographic Information Systems, and some people refer it to as Geographic Information Science. So, let's start off with what is GIS. And as I've said in our intro, in order to understand what GIS really is, we need to understand what geography is in the first place. Now, there are many different definitions for geography, and I don't start off on this tact in order to bore everyone. But why we start off this way is because many different people have different definitions and ideas of what geography really is. And fundamentally, what geography is, now get ready for it. It's can be really oversimplified, but also very enlightening as well. Geography is the study of anything in any given space. You're like, whoa, that either confused me or helped me. So, on planet Earth, think about the space that you're in right now. I'm in my office, but I'm also looking outside. I'm sitting on the second floor and I'm looking outside into my neighborhood. And in my neighborhood, I can see the human environment, which is built, roads. I can also see other structures. Those are also human made. Those are human constructs. I also see the natural world, the physical world. I can see the mountains in the distance. That's the physical world. I can see trees and plants everywhere. That's also the physical world. Down the street, there's a creek. That is the physical world. So the reality is that in geography, we get to look at both. We get to learn about the human side and the physical side. And even better, we get to bring them together. So think about the environment that we live in, the trees, the physical, the creeks, the mountains, especially around where we live, the volcanoes, and how that affects our daily life, what we can do, what we can't do, and how we behave. So, in the last few days, we've had a lot of heat. How has that affected your days? Now, in June, we had a lot of rain. Maybe that affected some of your holidays or outdoor activities that you were having or would have had or were planning on having outdoors. Whereas if you live in a different space, maybe depending on where you're at in the world, you're able to get outside and have functions outdoors. It affects what you wear, what you do, and essentially how we as humans behave. So, geography is that study of anything that you want to study in a given space. You get to define that space and what you want that area or that scale to be. So, for many of you, you might be more interested in the physical side of, or the science based. You might be water engineers. You might be looking into fire science. Some of you might be social scientists, and you might be looking more into demographics or income. Can geography do both? Yes. Are there geographers that do both? Yes, absolutely. So that's where geography to me is the most amazing subject, because you can study anything you want. Just tell me what space you want to study and tell me what your interests are. So, geography is the study of places and the relationships between people and their environments. So, as I've said previously, we have the study of physical geography and we have the study of human geography. Maybe you've had the opportunity to take both. And if you haven't, I really encourage you to do that. So, for example, at Clackamas Community College, I teach regional geography of the United States and Canada. That is just a super fun class where you get to go all around the United States and Canada and just learn about the qualities and characteristics of those locations and those spaces. Now, in human geography, we get to learn about culture, like language, um, belief systems. Some people will call that religion. You get to learn about race, ethnicity, and nationality, and the rise of nationalism, if you will. When we teach physical geography, and I also teach physical geography as well, and environmental geography, we get to learn about how the natural world, the atmosphere, soil, streams, landforms, anything climate has to do, the atmosphere, how that in turn works and functions, and then how it interrelates with human geography as well. So, can't say enough about geography. So, what questions does geography ask? Geography asks a lot of questions. It asks the where. So, where are you right now? Think about the weather, think about the physical aspects, then also think about the cultural and the human side as well. Then we get to ask, where is that location and what is at that location? So, as I've said, again, thinking about where I'm sitting right now in my home in a human built environment. And some of you might live in a place where you look out your window, you might not see other human constructs at all. You might just see physical landscape. Then in geography, a very important aspect is the temporal, meaning time. So when was it? When? So in geography, we study space and time. We study the spatial, which means space, and we study temporal, which means time. And then we get into the why and the how. So, for example, if we're going to be taking something from physical geography, where in Oregon was, where was there less precipitation during 2019 than 2018? So we can talk about that all day long. I could show you a spreadsheet of that sort of data. How would you prefer to see this question communicated? Now, as geographers, most geographers will always answer a map. What is the tool of geography in terms of communication? And that tool is the map. That map could be a static map, a map that doesn't change, right? A map that you're looking at behind my wall. Obviously, that's National Geographic. I have other maps as well. All maps are meant to communicate different things. So we could use a map to answer this question. Now, in GIS, we can make maps that change, that have layers, and we can answer those questions being able to turn on and turn off different layers, and then we can share those maps with others. Another important question that we can ask using data and spreadsheets as well, but also in a static map and also using GIS in a map that we can alter and change. What parts of Portland have a ground slope greater than 15%? Ooh, that gets me excited. Now, in Clackamas County, how many places are there where a road crosses over a river or a stream? Now we can count that, we can quantify it. I can, again, show you in a spreadsheet. I can tell you about it. But how personally would you like to be able to learn about the answers to these questions? Now, research tells us that 85% of humans, the number one way that they want to see these questions answered is visually. Geography is the most visual subject on planet Earth. We're very visual and that we love photos, we love descriptors, we love charts, and above all else, we love maps in order to communicate questions, curiosities, or information that we might have or that we want to find out. Now, in terms of human geography, we can answer questions as well. Where in Portland are households located more than 0.5 miles away from a TriMet stop? How about from a park, right? It's really big in the city of Portland. They really want people to live short distances to a park as well. We can answer that using GIS, making a map to display this communication. During the 2016 presidential election, what was the voter turnout in Oregon City area House districts? We can also communicate that using a map as well. In Beaverton, how many households are located in the 100-year flood zone? I think a map would be an amazing way to communicate that data. And honestly, for this last question, probably the only way. Astronomy asks questions about stars and planets, etc., and it requires specialized tool and knowledge. Here are some examples of that. Geography does the same thing. So let's think for a second. Could we say that GIS is specialized tools and techniques that are designed to address geographic questions? But that's part of it. It's not all of it. We're almost there. Let's see if we can get a little bit more precise. Because we're learning right now essentially about geography. Our goal is to get you to learn about geography and then take it another step into GIS. You're like, I'm not a geographer. I've never wanted to be a geographer. That's absolutely fine. But in order for us to understand, appreciate, and utilize GIS to its full capacity, it does require a nice foundational background in geography. So, geographic information systems are tools that allow for the processing of spatial data. Now you're like, spatial data, what are you talking about? Remember the word spatial means space. In geography, we can study anything in a given space. I gave you an example of some questions that we can answer in physical and human geography, which one you're probably in one of those areas. Are you a more science-based or are you a more social science-based person? Maybe you could be more liberal arts, like art or language, something along those lines. You can also make maps for information or questions you might have in those disciplines as well. So essentially, these questions, we could come up with data, information. It could either be qualitative, which is obviously not quantitative. Qualitative is when you ask open ended questions. Quantitative is going to be data that's numerical in nature. So we are going to take this data, this information, and we're going to tie it explicitly to and use it to make decisions about parts of the earth. Like the field of geography, the term is difficult to define because geography integrates so many different subjects into one. Now, as of the late, gosh, when did I start getting into GIS? When I was in university donkeys years ago, geography became a place that was also technical. We were always technical in that we made maps, but we became even more technical when we started making maps using computers. So now geography has a computer-based system to aid in the collection, so collecting data, maintaining data, storing data, analyzing, outputting it, and then distributing it to others. So now think of the subject that you're specifically in. What questions do you have? What might you be working on? Think about the data that you're collecting or someone else is collecting. So now geographers and geography has this tool where we can bring together data. We can do all of these things with it in order to make maps that change over space and time. Remember that word temporal, so that we can get better at answering these questions and also communicating this to others. Here is another term or another way that we can define GIS. It's a system of hardware, software, and procedures designed to support the capture, management, manipulation, analysis, modeling, and display of spatially referenced data for solving complex planning and management problems. You're going to see that was written all the way back in 1989. So now, what is GIS? Many different definitions that allow, but all follow the same pattern. They're specialized tools and techniques with certain characteristics that are designed to address geographic questions. But geographic questions, really, what are they? You're just wanting to know what is happening in a certain space. What space is that? You get to define that. So GIS has many definitions. And there they all are. Now, we also are going to be using data that's spatial and not spatial. So it is a partnership between spatial data and non-spatial data to visualize geography and solve problems. So sometimes we are going to have information, like think about, for example, something in your field. If you're talking about water management, you might have a given space and you're going to have data that's going to relate to that given space. So you're going to have a spreadsheet for that spatial data. But some of those points within that area might have information that's not spatially related. So it's amazing. You're going to be able to click on a point on a map and bring up data or information about that point that might not be spatial, and that's fine. So here is an example of what we would utilize for data that is spatial. Here is a given space that we're looking at. The buildings are highlighted in blue. Obviously, we're looking at aerial imagery. Now, here is the attribute information, or the information about each of these spatial points. You'll notice that each of these points is a building and has an address. So we have put together all of these points and then information about these points. So this is attribute or information about that specific point. Here are some examples. Here are county boundaries in the United States. The information you're looking at here is spatial, right? We're looking at a certain space, although it's really ginormous. Now, here are the attributes or qualities or characteristics or data or information about each of those counties. Population, the size of it, the population in 2010, and then other demographic information. So here is non-spatial data, but we've put it into a space that is obviously spatial data. So we're having the two come together and represent information that we are communicating. So you're looking at information here that we're in turn going to be we're ending up communicating in a very spatial way using a map. Let's take this a step further, and you're going to notice that, that we're showing the population per square mile of the lower 48 counties. And so we were looking at a graduated legend over here according to color. Now, the counties with the higher population are going to be darker. So, what is this map communicating to us? It's showing us the population in 2010 per square mile. And you can see counties that are highly populated. Again, here is that same information, but it's being communicated to us in a non spatial way. I don't know about you guys, but which one do you like to look at? I'm a geographer, so you're going to be able to know the answer to that question for me. Now, what are we looking at here? We are looking at the average household size by county, according to the lower 48 states. So, again, we are taking that data, that table, and we're visualizing it. Now, what makes GIS so unique? You might think to yourself, this is pretty basic. Why wasn't this ever done before? So, queries are questions and layers. So, you can click on and off these layers as you choose. As you just saw in the previous examples, we can click on and click off any of those attribute tables that we want to. Layers can be added and removed at any time, and the relationship between these layers can be analyzed. So if you're like, is there a connection between, let's say, for example, population and the average household size in some of those counties? How is it related? You can have two of those layers, you can click them on and off, and then you can analyze and look for some sort of relationship. You can find relationships in something that's non-human geography based as well. Think about that if you're in a science. Think about a question that you might want to be able to answer using some of those characteristics as well. So GIS layers and search query, right? Because you're looking for a question capabilities, allow us to ask 5 fundamental GIS questions. First and foremost, location. What is at this location? Where is it? And what has changed? So this is the temporal aspect, the time, space and time. And if we wanted to model this, or what if this happened? Fundamentally, geography is looking for patterns. What pattern exists? Do we see something that connects with something else? What is the relationship between two or more of these layers? And what geographic variations exist over space? How did we notice that some of those counties had more population than other counties? What connections could we find there? How about in demographic information? Income? How about ethnicity? What other patterns would we be able to find? What else can a GIS do? It reveals information that is otherwise invisible in a non-spatial format. So again, we're able to take non-spatial information, like for example, ethnicity or income level, and make it visual for others in order to communicate that. It performs operation on spatial data that are too tedious, expensive, and inaccurate if performed by hand. So we're going to be able to upload this information and put it on a map and then share it with others. Once your layers are brought into GIS, they can be analyzed alongside other layers. So the software that we've used in the past is QGIS. We're not utilizing this anymore, but I wanted to go ahead and reference this because this is a free resource that if after this class, after your year license ends, you would want to be able to utilize free software, QGIS is a great place. However, we do not teach in QGIS any longer because the industry standard is ArcGIS, ArcGIS Pro. So if you are going to go out and start working with people and teams that are using GIS, they will be using ArcGIS Pro. The company that designs this software is called Esri. They're located in Redlands, California. What are the components of a GIS? So hardware, you're talking about your computer, the software, which we're downloading, data, which we're going to be uploading from projects, methods that we will be learning, people, you and I learning how to do this, and then a network to be able to share and come together and collaborate on maps and projects and working really as teams. What you'll notice now is that within data science and really anything technological is that the need for people not necessarily to be a GIS analyst or even a GISer. What is on the uprise is that there are people that are needed that can be on teams with people who are in data science or who are in GIS. So that is one of the really big reasons why GIS as a course, an intro course, is so important, is because now you're going to be able to, after this course, maybe not ever do GIS again, but to be able to be on a team and to communicate and understand and value what's going on and why the GIS team is doing what they're doing. So that say you're out collecting data, or if you're working out in the field or even in the office and working together collaboratively with other people in your organization, whether public or private, you will know what is happening. It's really important. So again, you can go ahead and click through this. I offer this as a video, but then I also offer it as a PDF as well. So here are some examples of GIS data. We use various layers to explain or display or communicate data. Each layer type is going to be a data model, and you can create a GIS map with any combination of these models, as long as they are in the same geographic location and referencing system. Next, we're going to be learning about the data models and the different kinds of data, but I'm going to save that for a different video. Our next video, we're going to be talking about vector, raster, and more about data models and what GIS really looks like. So if you have any questions about anything we just went over, please make sure to reach out to me. I'd love to meet with you anytime. Let me know when we can make that happen.